Hello, my name is Joe Pranovich, and I'm here to present for you today importing TinyDNS to Amazon Route 53 in Python. This project is very important to me. Enterprise organizations, such as the one that I work for, have many thousands of domains, and many times that the number of domain records. While Amazon does offer a robust platform for hosting these records, it has relatively weak support for importing them. For example, you can't use zone transfers, and the converters for converting bind formatted records are all written by Amazon users rather than Amazon employees. Of the tools that end users have provided thus far to Amazon, none of them meet my need, which is to be able to import a TinyDNS formatted zone file. Let me tell you a little bit more about TinyDNS. TinyDNS is actually part of a suite of products called DJB-DNS, created by Dan Bernstein in 2001. This suite includes caching name servers and other tools that a domain name manager might need. The intention behind TinyDNS was to be a more secure alternative to bind, as well as to have a simplified configuration language. TinyDNS is open source, and since 2007 has been open sourced in such a way that it can be used by an increasing number of Linux distributions. Amazon's Route 53 service is a cloud-based DNS provider. While it does not yet support all DNS features, it does have a fairly robust XML API as well as a web dashboard for editing records. It also is very highly performant, much more performant than an average enterprise could do on their own. I chose to do this project in Python because I felt that Python was a better language for system administrators. Running this in Java on a Linux machine may not be the most ideal choice. Starting this project, I quickly discovered that Python is not one of the languages that has an officially supported software development kit by Amazon. Many other languages are supported, but Python sadly is not. Fortunately, there is an alternative, and it is an alternative that is embraced by Amazon. It's something called Boto, and it supports many Amazon features. Unfortunately, this did not appear to be very mature for Route 53. The documentation was poor, and I was unable to get many major functions working without actually manipulating the XML. Since I wanted this to be as pure Python as possible, I felt that an API that required me to go under the hood and manipulate XML was not an API that I wanted to deal with. This probably works very well for other Amazon services, but I suspect that this explains why Amazon has not yet embraced this open source project as an official SDK. After casting about for a while, I was unsatisfied with the Boto library. In fact, I threw out all the work that I had already started with it. I considered writing my own library from scratch and making that into this project, but a few Google searches later I discovered the aptly named Python-Route 53 library. This library is not supported by Amazon, but is a simple way that you can manipulate Route 53 services from within Python. It still has bugs, perhaps more than a few, but they're different bugs, and I was able to ultimately get it to work. Installing this library is easy if you already have pip installed, and installing pip isn't that hard if you already have Python installed. And I was able to install it just by running sudo pip install route 53. It downloaded some things, it spat out a number of errors, but ultimately the library was installed correctly and I was able to get it to work. With my development platform selected, my next task was to determine how to import the TinyDNS data files. These files are a little bit complicated. They look very different from bind files if you're used to seeing those. And basically they consist of individual lines, each of which refer to a single domain name record or a single piece of a round-robin record. Each line starts with a special character. In this case, you can see from this slide, I have special characters Z, ampersand, plus, equals, C, at, and others. Each of these special characters refers to either a specific type of record or a very special TinyDNS record. So for example, Z is the SOA record. The ampersand is an NS record. The plus is an A record. However, the equals sign is an A record plus a PTR record. This makes it easy to build a full zone using a simple file, but also makes it so that records do not have a one-to-one mapping with what is actually going to be exposed by the DNS. This represented a key challenge. There are other key challenges that I experienced while importing this data. First, Amazon does not support a feature called Split Horizon DNS. This is a very common security feature for enterprises, and one that TinyDNS does very well. When you do this, for example, you would not want your development machines to be known, or their addresses to be known on the public network. However, within your company, you might want your development machines to be able to be found. Split Horizon allows you to not serve the name of your development servers unless you happen to be connecting from within your office. It's a very useful feature and one that Amazon does not support. Amazon does support a basic geo-targeting feature that allows you to identify which local Amazon cluster you would like it to point to, but that feature is not compatible with TinyDNS or the general Split Horizon. Another challenge that I experienced was converting round-robin records. In TinyDNS, a round-robin record encompasses multiple lines. However, in Amazon, these are all reflected in a single record set. I would have to be able to parse my DNS record files, or my TinyDNS record files, in such a way that I would be able to identify these round robins and make sure that they were put into the same record sets. As I said before, TinyDNS supports convenience records, which are a combination of several real records. The one that I defined earlier, the equal sign, is an A and a PTR. However, there are other records that can make 2, 3, or even 4 real records using one single character. And finally, I discovered that TinyDNS is more flexible than my own use cases would have admitted. You can have multiple zones in a single zone file. I don't know why you'd want to, and I certainly don't do it that way, but as a result, I was unable to work with all the possible ways that TinyDNS is legally configured and focused on the ways in which our organization configures TinyDNS. When I implemented this project, I implemented the code in 3 phases. First is preprocessing. In the preprocessing phase, I'm reading in the TinyDNS data file, I'm removing comments, as well as processing out all of these special records, making it so that one of these records that is an equal sign generates both an A and a PTR. Well, in this case, I'm not actually handling PTRs yet because PTRs would require a separate zone file, but I think you get the idea. In the second phase, I'm loading the data into a complicated data structure. It's actually a dictionary that contains a dictionary that contains a list. And anytime you have a data structure that's that nested, I just think it's awesome. The outermost dictionary of the data file is a list of record types, A, CNAME, NS, MX, etc. Under each of those record types is another dictionary of all the different names that you will find in your zone file. In this example, I used loadbalance.mockup.com, which you would have seen from a few slides ago, and that contains a list which has multiple IP addresses underneath it, in this case 127.0.0.1 and 127.0.0.2. If it doesn't have it, if it doesn't have multiple records, it will still be a list, it will just be a list of one object. So this dictionary of lists is a good way of representing the entire scope of a single TinyDNS zone at the cost of being a little bit complicated to set up in Python. The third phase is the fun phase, and that's actually creating records. And more than just creating records, you have to first identify if the record already exists. Because if it does exist and you add it again, you could get an error, or you will get an error. And if it does exist, you have the ability to just edit the object in line, making the changes that you want, and it'll automatically be committed by the library. If it doesn't exist, we can call a method, for example in this case, create_a_record, with appropriate parameters to create the record ourselves. After successfully completing the first version of the code, I was able to import many different record types. This specific version of the code does not yet have a full set of features. It doesn't include support for everything that TinyDNS can do. It doesn't support everything that Amazon can do. But it does successfully import several record types, build zone files, and make modifications when they're detected. I'm able to verify this by going to the Amazon Route 53 console and opening up the zone for mockup.com in the web interface. But this data is not just available in the web interface. These records are live. Now, you should know I don't own mockup.com. That would be awesome, and if I did, I would have sold it for a lot of money. However, Amazon doesn't know that. When you give a zone to Amazon, it's going to return records for it whether or not they're live on the internet. In this case, they're only live if you look for them if you go to the direct Amazon server, and I can, using the dig command, digging at ns1118, blah, blah, blah. This is the name server that Amazon defined for me. Looking up a name, and I can see that it's there. Excellent. If you have any questions about this project, if you'd like to learn more, if you'd like to get a copy of some of the code, I'll be happy to share it with you. You can email me at jpranovich@gmail.com. Thank you very much for your time. I look forward to your questions.